Hey guys, this is Farron, and I'm going to talk to you today about the M&M and water lesson plan. The context of the lesson, the content area and grade level is for chemistry grades 10 through 12. The text is called What's Going On Here from the American Chemical Society, and the genre would be informative nonfiction. It would probably be part of a unit on electrical forces and molecular movement. The standards that this lesson fits under are the high school physics lesson, which also is included in chemistry, to plan and carry out an investigation to gather evidence, to compare the structure of substances at the bulk scale, to infer the strength of electrical forces between particles. The supporting literacy standard is to analyze the structure of the relationships among concepts in a text, including relationships among key terms, for example, force, friction, reaction force, and energy. The learning outcome of this lesson is that after seeing the M&M and water demonstration and reading What's Going On Here, the chemistry students will be able to design and complete their own experiment to test other variables dealing with solubility by writing in their lab notebooks their hypothesis, procedure, and findings in the scientific method format with 100% accuracy. Both the discussions after the demonstration and after reading What's Going On Here will provide me with an idea of what my students are understanding thus far about solubility. From here, I will know if I need to explain the text further or if they are ready to move on for a formative assessment. For summative assessments, reading the written copy of the experiment results and conclusions that students put in their lab notebook and their final presentation that they give to the other M&M experts will show me exactly what students have learned throughout the lesson. To differentiate content, there is the demonstration for visual learners, handout and note-taking for linguistic learners, lab for kinesthetic and visual learners, and a raft assignment for the creative students. My high ability students are always questioned deeper when I'm walking around to check understanding. The different variables the students could test allow for different depths of understanding and knowledge to be attained by the variety of students' learning levels. I will lead my high ability students to think deeper and plan a higher level experiment. Before reading, I'll show my students the M&M and water experiment and ask them to write down in their lab notebooks what they observe. Once they have it written down, I'll ask them what they think is happening. Based on your observations, what do you think is going on in this experiment? Once we have a discussion on this, and for a couple minutes, I'll ask them to read the handout from the American Chemical Society called What's Going On Here, to see if they can figure out why, at the molecular level, the M&M's sugar is dissolving off. As they read, students are encouraged to highlight and underline words they do not know, take notes in their interactive notebook on the electrical interactions of atoms, be thinking of a way to explain what is going on in the experiment to their group members, and brainstorm different variables they think may affect the solubility of the M&M. After reading, students will answer the 3 questions at the end of the handout. They then collaborate with their group members what they conclude about solubility from their background information, the experiment, and the handout. As a class, we will then list some possible variables that could affect solubility. Students will pick one variable to test and receive a partner from me, then work to write a possible experiment that can test their chosen variable efficiently. Here's an example of the raft assignment I'll hand out to my students. For this assignment, you pretend you are an M&M expert who is going to give a presentation to other experts about the solubility of the candy. Design and write down in your lab notebook an experiment to test one and only one variable that may affect solubility following the correct steps: purpose, hypothesis, procedure, results, and conclusion of the scientific method. Then gather the materials and apparatus needed to carry out your designed experiment in class. Be sure to come up with a written conclusion that tells the other experts what your results mean, and put your hypothesis, procedure, and all your findings in your lab notebook. Students will then be given their partner based on skill level and interest in certain variables, and allowed to look at the materials I have in the classroom to come up with a way to test the variable they have chosen. They are required to write it in following the scientific method. This means they need to include a purpose, hypothesis, and procedure. As their experiment continues, they will need to record observations, results, and a conclusion as well. After I approve their plan, they are free to gather their materials and conduct their experiment, making sure they record their results in their lab notebook. During this time, I will walk around and check understanding by asking them questions or answer any questions they may have. Once students are done testing their experiment, they must clean up their lab station and return to their desks to discuss what their findings mean. Once everyone has finished, groups may begin presenting their findings to the other M&M experts in the class. This way, students will know that what the other groups discovered about solubility, and a class conclusion on solubility of M&Ms based on all their experiments can be created. This is the end of the lesson, and I will close with a discussion on how your findings compare to the information found in the handout. What variables didn't seem to affect the solubility, what variables did affect how the M&M dissolved, and how do you think this works at the molecular level?